Yes, sir.
Okay, so in our last class, we discussed about the use of structure and class and how we encapsulate related methods in a class or structure. So this was actually the first object-oriented feature that we actually used explicitly. So, okay, so in this class, and what we found is if the this all the methods are written within the the details of the methods are written within the structure or class definition, then it becomes too lengthy to follow it up, and also it becomes too difficult for the reader to know how many methods are there and what are their interfaces. So this is a more compact form, and this is recommended, where you actually include the prototypes, either public or private, and then end the class definition, and then you define each of the members separately outside the actual definition here. And when you do that, you use the scope resolution operator to specify that this definition, whatever it is there, it is referring to the method f1 that is belonging to the class yy, and this definition, whatever it is, belonging to the method, the name of the methods can be the same in two different classes, so belongs to f1 which belongs to class xx. Okay, so that is some of the syntax that we talked about. And whenever we have got this encapsulation, using the dot operator, we can call those methods or invoke those methods. So that is a normal thing, and provided these are public. And one difference is, if we encapsulate, when you invoke the method, you actually use the object name, and through that you invoke it, so you don't have to pass it explicitly. Okay, so in this class, in this particular class, we'll try to do things in a different way. So the same structure, or the same stack, we'll try to do things in a different way. So what we did here, okay, so let us talk it like this. See, if we have got a class definition, class xx, int say a, and let us assume that everything is public right now. So then we have got init xx, the initialization method, okay, which has got which will take some input integer x, and it will assign a the value of x, and it will have some float pointer p, and it will assign p some dynamically allocated space initialized with value say 5.2. Okay, and we have got something else like say display, which accepts void, returns void, it returns void, and we have just cout a and cout asterisk b, and we have delete or destroy xx, that will do just the opposite of what initialize does, means delete p, and that's the end of the class. So is this code clear? We have got a class definition and we have got everything. So what I need to do here? So this is a class definition, and how many methods I have got? 3 methods. And because these are very few in number and the length of the methods are also uh, small, so I have, or maybe that I do it like this. So can you all see what I did? So this is there are 3 methods, these 3. So these 2 I have defined here itself, but this one I prefer to declare outside the definition of the class, end of the class. Hello, am I audible?
Yes, sir.
Yes, sir.
So I prefer to choose that route, like to uh, define this particular method outside the class definition. So I just define the prototype here. So these 2 definitions are here itself, but this one I prefer to do it outside. So following the previous syntax that we discussed in the last class, what should I write? I would like to define destroy xx, the same syntax prototype that has been defined there, that has been defined and declared there, and the details of the body should be here. Delete p. But if I simply write this, what is the problem? This destroy becomes just an isolated function definition. We cannot say this is a part of this, this is a member function of this class, because it's just a name. So which particular class it belongs to, it's difficult for the compiler to identify or to note. So what do I need to do? If I would like to say that this destroy is actually the definition of this member destroy function, what should I do?
Scope resolution.
Can all others follow? So I have to write xx colon. Is that fine?
Yes, sir.
So the simple point is, you have the preference. You can, if you wish, you can write it here itself. If you wish, you can write it outside also. It's up to you. But it is always recommended that you should write all the definitions, no matter how small the function is or method is, outside. That's a good practice to follow, so that your actual class interface is visible within in a single shot to the reader. Okay. Now we are trying to focus on something different. So if this happens and we write here main, now say we want to create some instance of x, let it be say p or say r, and I would like to invoke. So this is just an object created. So object creation means what is done in terms of the memory, what is done. So this will be in the stack segment, right? So when you create this object, when you declare this object, what it means internally in the memory, what happens? What action is taken?
R is pushed into the stack.
Yeah, but what is R? What R is comprised of, or it composed of? An object means
Integer
what?
A, integer A and float pointer P.
If I write here xxs, xxt, so each of these are objects, and each of them, they will have what? Their own member. What should they all have? RST. These are all object instances of this class XX. So to work independently, they must have their own what
Member variables.
is all others. Can you follow? Can you all follow? What does a class consist of? It consists of member variables and these member methods, right? Now, when we create three instances, R, S, and T, so do you expect R, S, and T should have the same A and P, should operate on the same A and P?
No, sir.
No, sir.
So, and do you think that they should operate on the same methods?
Yes, sir.
So where does methods come from? Where the methods are stored, the object code of the methods stored. These are all functions. So when compiled, they will get the object codes, the machine, the 0 ones. So where they should be stored? Getting my question? Where these the what should be the object code of display, the init-x and destroy-x go? In which
Data
segment they should come from?
data segment.
Is it data segment?
Code segment.
Code segment. Can you recall? Code segment or text segment. Sometimes we call it text segment. This is what, and this one, and this, the individual objects which are local, non-static, they should come from the stack segment. Is that fine?
Yes, sir.
Now this destroy x, display x, and init x, where should they be there? So this is a destroy x, x. Then this is a init x, the body of the object code of init x, and this is a display, right? Now this, when you create R, what happens? When you first create R, then R requires definitely the space for A and P. So this is A and this is P for R, right? Now when we go for creating S, so can S, the first thing is we already answered that, can S share the same A and P with R?
No.
Everybody agrees to that?
Yes, sir.
So definitely it will be having separate space because it's a different object altogether, right? So this is say S. So this portion is S, this portion is R. But now for this S, do you need to have again object codes for display, int, and destroy?
No, sir.
No, sir.
So like if there are two sons, a couple has two sons or two daughters, like they take their dinner in the same dining table, but they have their own clothes and own, say, whatever, so the say mobile phone, something like that, because these gets changed. Okay, and this is the identity, right? So this is the identity of the S. So what is the value of A, what is the value of P, what is the value of A? So this will distinguish whether it is the object S or the object P. Sorry, object S or object R or object T, right? But when they think of operating something, some kind of behavior, because they belong to the same class, their behaviors are same, and because their behaviors are same, they can all execute the same uh, code corresponding to that method. Are you getting the point?
Yes, sir.
So when you go for allocation of T, what happen? What happens actually? Got it? Is it visible?
Yes.
Yes, sir.
So got it? What happens when you go for T? So when we actually declare objects, this is what happens. So this is for R, what actually gets allocated. What actually gets allocated? It is the space required by the by its data members, right? Whenever we declare an object, some space requires to be allocated, as like declaring variables, normal variables. So for an object, it may have multiple member data. So taken together, the entire space will be allocated accordingly. Is that part okay? But the code segment, it will have only one copy of the behaviors or the methods or the procedures that they will all can share or operate on. Is that part fine? Is that idea clear?
Yes, sir.
So first of all, my question is, if I write size of R or say size of XX, then what happens? What do you expect? See out size of XX. What do you expect?
The size of int plus
Int
float.
plus
So do you think that when you consider the size of this, you truly require to include the size of these code segments also?
No, sir.
Because they are all basically shared, right? So when I say that how much space a student requires in a hostel, it is basically the exclusive space that is given to him. We don't say that, okay, the student will have one room and also some portions of the common room and the dining room and the toilets and all this. It's not like that. So we just said, so the thing is, when we compute the size of size of a instance of a class, size of an object of a class, how much it should compute, how much it should evaluate, the exclusive part, which actually is also the identity of the, which carries the identity of the object. Is that part, are you convinced? And that should be the case, right? But in true sense, you see, a class will have some data members, some methods. So you'd say that means an object should also have the space for data members and space for the methods. But because the methods are shared like this, we ignore it. So we don't have the overhead of assigning methods or space for the methods. Is that part completely clear to you? So those who are switching from C to C++, so that should be there. So it is not only we are encapsulating, but through the encapsulation, we don't require space for the objects, sorry, the methods corresponding to each objects separately. Is that part okay? Okay, so now if I write r.initxx, will it work? So first of all, this answer will be, how much will be the answer? Say it may be 8 or 6 or whatever. So this I know. So the size of int plus float, that is fine. So now if I write r.initxx, passing some values at 10, will it work? Hello?
Yes, sir.
Will it work?
Sir, everything is public, right?
Yes, so the problem is you are invoking this member method, you are invoking the member method of R. But the problem is, because it is a class, everything that we have declared, this, these members, all the members, methods and the data, these are all treated to be, by default, they will be treated as
Private.
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 So there lies the problem. So you have to be either explicit or you have to make it. So let us assume for this particular case, we just make it public, right? So everything will be public. So in all these will be treated as public. So now there is no problem in calling this or this. Okay. Now if I would like to initialize the object s, I would write s.initxx with some value, say 5. Okay, so like that, and s dot destroy xx like this. So the methods, they are using the same, but the methods operate for, in case of when s calls the method, it will be operating in this particular space. When r.display or r.initx is called, it will the same method will operate in this particular space like that. Is that part clear?
Yes, sir.
Okay, so one simple question: can we have a class something like this? Can we have a class yy, say maybe it is public or private, hardly matters, init x, sorry, say function something is written here. Can we have a class like this? Can we have a class like this?
Yes, sir.
What are the differences between these these two classes? What is the speciality that we can see?
One has only member method, one has only member variable.
There is no data members here, right? And here there is no member methods. So this is fine. Now my question is, if I write size of yy and size of zz, what do we expect?
1 byte and 4 byte.
YY is 1 and ZZ is 4.
Why it is 1?
It is the minimum
I'm
space
asking
that.
yeah, so I'm asking the question to others. So just now what we mentioned, just now what we found, size of an object is equal to the what should I write? Equal to hello,
Size of the data members.
is equal to the total size of all its data members, right? So this is fine. Now if I go by that definition, it has got no data members, so what do we expect? It should be 0, right? This is just now we found size of an object is equal to the total size of its data members, and that is indeed what is happening. So size of zz should be maybe 4 if integer takes 4 bytes, but size of yy should be 0. So will it be 0? I'm asking the other students.
It should be 1, right?
Yeah, so why it should be why it cannot be 0? So now you say, so the first thing is what we found is the identity of an object is manifested through its presence of its data members, right? That's true.
Yes.
That is how. So identity of these objects rs and t is manifested through its presence of a data members, right? And if somebody is not having data members, so that cease to exist, right? So either you don't allow this to happen, this kind of declaration to happen, and if you allow it to happen, then you have to have something dummy. Are you getting the point? Got the logic?
So what do you mean by dummy? Like, can you explain it again?
Yeah, so that's how I'm coming. So first of all, if I allow this to happen syntactically, that means something need to be done through which the creation of say yy, if I say yy a and then zz say b, so these are two objects, right? So a is object of a and b is object of zz. Another thing is, when I go for allocation in the stack segment, say maybe that this is all local non-static. So in the stack segment, when I go for b, I know that for b how much space? 4 bytes. This is for b. This is for the object b. and these are the 4 bytes where this X is actually the data member is stored. But if I allow this to also exist, or this to be accepted by the compiler, now for A, nothing needed to be actually allocated because there is no data members. So what do you think? What is going to happen? Now how A will manifest its presence that I am there, and still you can write A dot fn1, because if A does not exist, you cannot do that. So if you do that, that means A should be there somewhere. Its existence should be felt in the memory. So how it can be felt? What is the solution? Are you getting my point?
A Boolean dummy variable.
So there comes a dummy. So you say that, okay, if he's nothing, having nothing, so let's have just 1 byte which corresponds to A, and what will it store here? Will it store something? Hello, are you getting my question?
Yes, sir.
So this is there, but there nothing you can store, because you cannot address, or you cannot actually, this address is also there, but you cannot actually operate on this space. This is basically a dummy allocation, you can think of. Okay, so maybe something like this. Say we have got the full-time research scholars and the part-time research scholars, so PhD scholars, right? Part-time research scholars. Although you have not seen our department, but our department has got say 50-60 PhD scholars who are full-time, and there are few like 10, 12 or 15 part-time research scholars, those who come occasionally, maybe once or twice in a week, or maybe in the evening hours. They work in these some of the local colleges, or maybe sometimes in the industry also, right? So this YY class is something like a part-time kind of thing. So now how you know that? So for the full time, they have got a desk, they have got a machine is allocated to them, a chair is allocated to, you know, that that particular full-time scholar sits in this particular location of the department. You know that he has got an identity in terms of the uh, the belongings that he's having in the department. Am I clear? Hello?
Yes, sir.
But when it comes to the part-time research scholar, so he occasionally comes. So we generally don't give any separate desk or table or something like that. So it's something, so they don't have any space, but still you say that they're the scholars and they have got their identity. So might be that you just leave a chair for them, just a small chair. But whenever you come, you will occupy this chair and sit in your and work in your laptop, something like that. So a chair does not have a full-fledged, all the facilities. It does not have a desktop. It does not have a other facilities. So it's something like that. So this dummy, if you ask for the space, what it will return? It must return something. So it will return just 1 byte. So 1 byte is the dummy byte. So it is dummy byte, which is used to track the identity of that particular uh, object of that class, any object of that class. If you say I have created another one more, say like C, so C also will have just 1 dummy byte uh, as per its identity. So if I write C out A, it will give, say if it is 2020, it will give 2020. If I write C out B, that also will give some address. If I write C out C, so each one will have, so because they are there, they have actually been allocated some space in the memory. So each of them, they will have some address. Okay, so this address. But you must know that this space is basically meant for nothing, is not basically of any use. Is that part fine? Okay.
Yes, sir.
So to summarize what we say, when you define a class generally will have data members as well as methods together. But sometimes you may tend to define a class which is having only a list of member methods, but no member data. That appears to be very strange, but sometimes we do that. We'll see some examples where it may be useful. Even if we do that, and that it means that the object is not requiring actually any space, but a dummy space is allocated to it. And if you ask for its address, it will return you the address of that particular location. If you ask for the size, it will just give you one. But for all the other cases, size of an object is equal to the size of the total size of the data members. So I can just append it a little bit. If there is no data members, then the size is 1, corresponds to the dummy allocation that takes place. So is that okay?
Sir, if there is a static data member, then what will be size?
If there is a
Static data member.
static what method?
Static data member.
Data member. I'll come to it later on. Otherwise, others they will get confused. Static, we'll have an extensive discussion on that. Static, constant, data members, methods, and then objects and all. We'll have a separate discussion on that.
Or sir, if we declare a void class, then what size will be 1?
We declare a
Void class. No data member, no member function.
no data member, no void function.
No data member, no member function.
Okay, I have not tried it yet. So yeah, probably that will also work. I got your point. So nothing is there, and I just have a class definition. Can I create a? I'm not sure. I have to check it. So you include nothing, neither members nor methods, and neither data nor methods, right? You
Yes.
still would like to have the class and its instance created. I'm not sure. Hopefully that also is allowed. That I have to check and answer. But for the static, I'll take the discussion in some other class. Let's make things simple right now, because others they will not be able to follow otherwise. So up to this part, is it clear?
Yes, sir.
So you can try and if you have the laptop, you can try and answer it immediately. Otherwise, I have to switch back and try it. So having nothing, whether it is allowed and what is the size of it. Hopefully it will be allowed. Okay. So okay, now the thing that I wanted to discuss is here. So class XX, and you have say let it everything be public. Let's not worry about the access specifiers right now. Make everything public because we would like to access them from outside. And for a real problem, once it given, then you have to apply your intuition and your design experience, that how much. And the basic principle is always like, if you don't require, just hide them. So if you unless you are forced to reveal the presence of those methods, or you would like to provide them as a interface to the user, because I'm writing the class means I'm writing the class for somebody else to use it, right? By creating objects, they will be using my class definition. That's the purpose. So the basic objective of object-oriented programming is to provide abstraction. So how I provide abstraction? So the thing is, you as a user should not be worried about how things are going on inside internally. So you should only know the minimal thing through which you can use the class facility. That's the point. So if you have say 50 methods, you need to define them for clarity, and also for to have a better control on the code and all this, the logic. because the cohesion rules and the coupling rules are still valid here. So it is up to you as a designer that out of those 50 methods, how many should I give to the user of this particular class for access. So maybe 4 or 5 or maybe 10, that's up to you. So you design it in such a way that the user of the code should not be bothered about so many the presence of so many methods, so many data members and all this. So let the user be interested in only the portion that is used. So like the students are the users of the facilities provided by the institute. So you are really interested in having the classes, having your extracurricular activities, and having your exams and certificates. That's all. And obviously getting a job. That's all. So you really don't care how the department is going on, where the faculties are staying, what is the campus problems, or the civil related issues, how the maintenance is going on in the departments, who maintains the server, what are the staffs, how they are paid, and all these details, right? So these are all hidden. So your interface is what? Register for your course, attend the class, appear in the exam, get your certificate, get your job, and leave the institute in the convocation. So there are very few interfaces that is defined for you, right? So you are not really bothered, or are not interested. So that's the thing. So as a design principle, you also should follow the same thing. No matter how many classes, how many methods, how many members you have declared, define, but make it minimally visible to the external world. So very few you make it public, only if it is required. Otherwise, you make it private. Is that part clear? Okay. So here, NIT XX int x equals okay, x then equals to x, and then destroy. I'll use the same code. So there is another pointer p. So p is new int destroy xx, delete p, and then display. Okay, now within the main, okay, let us write it here, main. I write here xx and then z. So I write here z dot init x with some value 5. It will work. Okay, and then here by creating another scope, if I write here xx something else, say maybe c, it will also work, right? And just focus on this. So I write here C out. Say this is initialization, so initialization. I give some comment, and here I write C out destroying. Okay, so if I run this code, what do you expect to be the output?
Initializing.
See, so this part is clear to all of you, right? Have you all followed? It's pretty simple. Everybody can follow the code.
Yes, sir.
So now let's come to this point. So in this, say, I call it is line number 1, executable statement. So what do you expect? Do you expect some output?
No.
No, sir.
No output. When you are in line number 2, what do you expect?
Init.
In it.
So basically init, like that. So in line number 1, what happens? In line number 1, what happens?
Space on the
A
stack is
space for
allocated.
this is created. So this is what is done in line number 1, right? And in line number 2, what happens? It displays the init. And then if I write here z dot So destroy xx. So then what do you expect? Okay, so do you expect anything here in line number 3?
No.
No, sir.
Nothing is there. And then here, what do you expect? It will call this and it will destroy. So this is also so up to this it is fine, right? Everybody agrees to that.
Yes, sir.
So now let us assume that I write something like this. I write here, instead of this, I write here just xx, and instead of this I just write here this. So got the change? I'm talking to those who are new in C++. Those who know C++ is very trivial. So can you follow the change that I made? What is this then? What are these? What are these? These are methods, right?
Yes, sir.
And if I change the name, are they still methods? These are methods, right? Because I just mentioned that I would like to change the name. I would like to rename those methods. Is there anything else that I mentioned? So they're still methods, right?
Yes, sir.
So now after doing this, if I run this code, so obviously now what you say that, okay, there is no init and display and all this. So this goes off, this goes off. And now I run the code. So if I run the code, because these are methods, so do you think that, so now I run the code. Now I write xxz. So can you tell me that what will be the output? Those who do not know
No.
C++, those who do not know C++, can you tell me what will be the output? There will be something magical. See what I did now. So I have created what? I have created an instance of x. I have created an instance of x here. Did I call any method explicitly? Did I call? Can you see any explicit method calls right now using dot operator and all this?
No, sir.
Is everybody convinced? Because there is no init xx not. So did we ever call any methods? No. So does it mean that you will not get any output? So what will be the output here? But we'll indeed get some output. And that is something strange and magical. It appears to be in the first time. So now when you, so now let us just remove it. Okay. So what I mean is something like this. I just write this one. So earlier it was output. Now I say that. So this is line number 1 and this is line number 2 within a scope. So when I execute line number 1, what do you expect? Definitely allocation will be done because I'm trying to create an object, right? Allocation will be done. Do you agree?
Yes.
So allocation will be done and there will be space for A and P. This is done. But additionally, something else will be done. So this function or this function here will be invoked, will be triggered. So this is a method, definitely it's a method, but this is a special method which, do you actually call it explicitly? Are you calling it here explicitly? But if you write it, you will get an output something like this, init, and then, so you will get init in line number 1. In the line number 1, there will be two things happening. So try to look into it. There will be two things happening. One is this one and one is this one. Got the difference? So once you see the display here, what you can infer? So that is the way to believe that that particular method gets invoked. Hello?
Yes, sir.
So those who write the codes for the first time, just write this small piece of code. Actually, I could have shown it, but again, there is some memory issues. I tried to resolve it, but I could not. Maybe in the next class I'll show it. So if you just write this, I have just renamed the names and rename the names in a special way. So what is the name given here? So this name is same as that of the class name. Can you see this? Name of the method is same as that of the name of the class name. So if you do that, then if you create an object of that type, then that magic happens. Like even without explicitly invoking this method xx, you get this executed. So these are special methods which gets executed during the construction of the object. Am I clear?
Yes, sir.
These are special methods which gets executed during the construction of an object. That is what is happening. If you see the output here, if you see that this is getting displayed. So because of this speciality that they are invoked whenever you whenever you try to construct an object, these are better known as what the term? These are known as constructors. So this is obvious because it helps. So it's a part of the construction process. So that's why you can call it as constructor. So constructors are nothing but methods. Now, can these constructors be private? Can these constructors be private? Are you getting my question? Hello?
No, sir, it can't be private.
So others, can you follow? So constructor is a method which is need to be invoked, which needed to be invoked during the construction. So if you make it private, so see, you are not explicitly calling it, but it is getting executed here from the public space, right? So you have to tag these constructors, these special kind of methods as public. If you don't do it, then it will be creating a problem. I mean, the compilation error will come. So the special methods means why is it specials? So these names are, so the name of the methods are same as the class name. So that's a specialty. So up to this, is it clear to you, all of you?
So it's a default constructor, right?
Hmm?
It's a default constructor, right?
No, it's not a default constructor. I'll
Then
come to
sir,
those terms. So uh, I'm not talking about any terms. So just try to focus on whatever I say. So because otherwise there are so many terms will be, so it will be difficult. So there are two groups of students: so those who do know C and I mean only C, and those who do know C++ maybe more than what I know. So that's a problem. So I would like to go step by step so that those who are switching to C++ or object-oriented concepts, they know that why it is required and how it is really done. I mean, uh, why it is actually required, how the design is like that, rather than just accepting, okay, I write a constructor and I'll write a destructor and all this. So what's the need of it that you should feel?
Sir,
Yes, there are default constructor. I'll come to it later on in some other class.
sir, a
So
constructor
hmm,
can be private, no?
yes, that is the point. So if a constructor becomes private, then what sort of problem will you face? What do you think? What is a constructor? Constructor is a method, right? That you accept because it is getting executed something written within it automatically. You accept that?
Yes.
So now if it is a method, so and where it is getting invoked, it is, you see, you are creating this object where within the main function. So if you're trying to create main function, main is not a part of this class definition. Main is completely outside. It's a outsider function. So within that function, if you are creating a constructor, sorry, if you are creating an object, so the object is getting created through this constructor method, right? Through this constructor method, the initialization of the object is done. So definitely, if you make it private, such construction is not possible. Am I clear? So one simple say change I have to make. So what is this? You see, this is a constructor method, but what it accepts? How many arguments it accepts? How many arguments it accepts?
One.
One argument. But will it work otherwise? Okay, I missed that point. Yeah, thank you. Probably that is the reason why you're asking this. So will it work like this? Now you say that the constructor is a method which requires one argument. Did I ever pass any argument here? It will not work. So I have to pass some argument, one argument that I have to pass. So if I write here say 5, then only it will work. Okay, that is a small mistake. I overlooked it. Now is it clear?
Yes, sir.
For the other
So we
students, yes, time is up now. Okay. Okay, fine. Maybe just take 1 minute. So if I write here 5, then only it makes sense. Okay, that's a reason probably you are wondering. So if I write here 5, only then it will work. That means it will invoke this one and it will automatically work. And these are the constructors, these are special names. At the same time, can you just quickly tell me what will be the output? So here within the another scope, there will be another object C created. So there will be another init. This corresponds to this one, right? And there will be space for this C also created, right? So there will be space for C and there will be space for Z. At the same time, it will be initialized with 5, it will be initialized with 9. So this initialization, space allocation, initialization, and the displaying, everything will be done. But when the scope comes out, when the control comes out of it, what will happen? Another, this thing destroy will pop up in your screen, because whenever you are coming out, you see this specialty. This is again the name used, but with this tilde. So these are called destructors. So you have the impact of destruction. So automatically, whenever you call this, here this will be invoked. And what do we expect? Whenever the control comes out of it, this object which got created, this also will be invoking destructor, this particular method automatically. So again, here the destroy will appear. Okay, so again, so in the next class we'll be talking more about this, the constructor and destructor methods and the use of it and why it is so essential. But hopefully I'll be able to display it in the by executing it. Okay, if there anything else, just ask me, otherwise I'll leave.
Sir, syllabus for C1?
Syllabus is up to whatever will be covered, because we'll take it in Friday, the next Friday. So up to Thursday, whatever will be there.
Sir, Thursday.
Yes. No, this
It
is
will
a
be.
just.
The exam will be taken on Thursday, sir.
No, exam will be taken on Friday, the coming Friday.
No, sir. I talked with them to take the exam on
But then it will be
Thursday.
up to Tuesday's whatever is covered.
Okay, sir.
Anything else?